I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Cybersecurity of DOD Critical Infrastructure. My name is Steve Orzala. I'm the CSIAC Outreach Manager. A few administrative notes before we begin. All phones have been muted except for the presenters, and today's briefing slides will be posted on our website within a few days. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. If we don't have time to address all the questions during today's webinar, we will post answers after the fact in our Cybersecurity Tech Forum. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIAC to conduct these webinars. My pleasure to introduce our lead presenter for today's webinar, Dr. Paul Losowitz. Paul works for Quanterian Solutions Incorporated and serves as the CSIAC Senior Scientific Advisor. As it turns out, Dr. Losowitz has several colleagues joining him today to support this webinar, and there is a great deal of information to cover. Therefore, I'm going to throw the briefing over to Paul now to start the event. So, Paul, the floor is yours. You can take it away.
Thank you, Steve. Next slide, please. All right, as Steve said, we have a number of subject matter experts here today. I will be discussing the Industrial Control Systems Joint Working Group results and some comments about DOD utilities privatization and its impact on ICS security. Sarah will be briefing for Sandia National Laboratories. She'll be talking about industrial control systems, behavioral analytics, and some of the projects that are going on at Sandia, some of which are for direct support of DOD. Jordan Henry will also be talking quickly because he's all haven't seen his full brief yet, but about the Scepter program. Ross will be discussing, Ross Foley from the PACOM J81 office, the Innovation Office, and the Energy Office at PACOM will be discussing MOSAICS and ICS Cyber Security project with support and funding, hopefully, by DOD as a joint capability technology demonstration. It is sponsored by both Northcom and PACOM. And Dr. William Wagaman from Sandia may be attending to add additional comments. Okay, next slide. All right, some of the quick topics that I will be discussing personally. The CSIAC is, as Steve mentioned, a DOD-funded cybersecurity analysis center. We are one of three. Our specialty is information systems and cybersecurity. We have a long history in cybersecurity. Most recently, however, with respect to industrial control systems, we completed a core analysis task for Air Force Space Command and Cybercom, doing an M&S modeling and simulation analysis for a unified platform. We just came back from Albuquerque attending and presenting at the Industrial Control Systems Joint Working Group. I'll be talking about some of the highlights, some of the takeaways that have interested DOD from the ICSJWG, and I will be also presenting a slide or two on a new effort brought to our attention by Schweitzer Electric on a tactical microgrid transition back to DOE. Okay, next slide. Quick and dirty. I don't know how many of you got any background in ICS security, so I thought I would do a few preparatory remarks on some of the recent events going all the way back, starting with Stuxnet. I have fond memories of Stuxnet, as you will see. This was the industrial control system cybersecurity attack in Iran at Natanz on the Iranian uranium centrifuges. The attack centered around the Siemens Step 7 software and controllers. There were 4 zero-day attacks used in this. The vector is generally accepted to be a USB attack. Personal note down there is I was stationed at the Office of Naval Research Global Prague office in the Czech Republic. When the news of Stuxnet happened, I was called up by the Estonian ambassador, having just returned from the Estonian Cyber Center of Excellence, the NATO Cyber Center of Excellence in Tallinn, and we proposed to jointly sponsor a workshop for the diplomatic community on the impact of Stuxnet. I was able to get Siemens at Erlangen to actually present at that workshop, which was the very first time Siemens in a public forum, quote unquote, came clean or discussed the full impact of Stuxnet and their involvement with their controllers. Next slide. So the ICS control systems attacks have become sophisticated and generalized. We see a proliferation of the attacks to Ukraine in 2014, some 4 years later, or 2015, excuse me. After the annexation of Crimea, Black Energy 2 and Kill Disk malware was found on Ukrainian national power generation sites. It was a large-scale coordinated attack, generally attributed to be a nation-state attack. It involved a phishing vector, and the payloads were Black Energy as well as a keylogger payload. The software signatures are detectable via Yara, and it essentially took down Ukraine's power grid for I would say, quick memory, it was well over 3 days before they stabilized. Next slide. Further target development occurred with crash override in 2016. In this case, it again is a supposed nation-state attack on a particular Ukrainian power relay station, which showed that, as a matter of fact, the perpetrators were able to do specific target development with their malware. The interesting part or impact to the United States was that it used an open platform communications protocol, OPC, which is fairly general and could be applied at numerous U.S. utilities as well. Next slide. So we now escalate to 2017, and we see HatMan. HatMan is an interesting ICS system attack insofar as it specifically focused on a security information system, an SIS, built by Schneider Electric. The purpose of an SIS is, in fact, to monitor the control systems in a the system is functioning safely and to degrade gracefully without causing harm to anyone or breaking any equipment. This was a case where the perpetrators, in fact, attacked a system designed for defense in depth of an operational site. The site happened to be in Saudi Arabia. The stories there on the links are instructional, particularly Schneider's comments about this. You can see the difference now between the original attitude in industry when Siemens was targeted in the Stuxnet attack and the HatMan attack with Schneider Electric. Schneider went through great lengths to cooperate and assist in the analysis of this particular attack, pointing to the importance of rapid and transparent response. Siemens, as a matter of fact, I am not trying to attack Siemens here at all. Siemens was the first one, and they eventually became one of the largest contributors to the responses and recovery actions for what happened in Stuxnet. Next slide, please. So this is jumping ahead a little bit to the ICS Joint Working Group. Idaho National Laboratories provided an exceptional technical description of what happened in the Schneider Electric HatMan exploit. There was, in fact, a zero-day used in this particular case. It elevated the admin privileges to the user level using a method that had not been found before in the wild. This whole attack required a deep understanding of the controller behavior in order to compromise it. And seriously, it produced no indications of compromise in the operation of the plant. The exploit was carried out while the system was operating, while the SIS was being used, with no indications of compromise. According to INL, this is difficult to detect in the wild. It does provide a full RAT tool, remote access tool, to the Schneider controllers. The attack is evaluated as being at least or more sophisticated than Stuxnet, and thus is attributed again to a nation state. And if you wish to have any further information on this, I can get in touch with Ian Wilson at INL and get you some contact information for him. Next slide. So as a result, we have seen that the interest in ICS cybersecurity or from a national security perspective is now very high. As a result, the CSIAC was asked to provide industrial control system threat models for a tactical DOD scenario. We provided some data and site laydowns, representative site laydowns from some site surveys we did to populate a modeling simulation cyber assassin model. We did this in conjunction with Metron Scientific out in San Diego for numerous Monte Carlo simulations of a particular tactical scenario attack. The rest of the information is controlled. I cannot say anything more about it. However, the agencies for which this was done were AFSpace, Air Force Space Command, and U.S. Cybercom. Next slide. That said, I want to point out the fact that why do we have all these DOE people here today? Well, I will say this, that DOD is not the lead in ICS cybersecurity. Primarily, according to our national regulations and laws, DOD is responsible for national security systems, which is specifically our military-specific, non-dual use C4I systems, command and control systems that have military application. Everything else comes under Department of Homeland Security. The national lead for cybersecurity is, in fact, for critical infrastructure is DHS, and this is in accordance with PPD 21, which I won't read to you there, the National Infrastructure Protection Plan for 2013, and the most recent presidential executive order on strengthening cybersecurity of federal networks and critical infrastructure. So DHS is, in fact, the federal lead for this. And we, as a result, have to work very closely with DHS and other partners. Next slide. DOE. Surprisingly enough, the Department of Energy has a lot of interest in energy control systems. They, in fact, are the de facto technical lead, and I say this not officially but unofficially based on my personal experience. They are the de facto technical lead with respect to cybersecurity of energy systems. Just recently, this year, the DOE Office of Cybersecurity, Energy Security, and Emergency Response was set up by Secretary Perry. The cyber part, Industrial Control System Cybersecurity Consortium, has incredible talent assembled to include Sandia, Pacific Northwest, and Idaho National Laboratories. And we talked earlier about Ian Wilson at INL. Incredible talent there, and you will meet some of those people today. As a side note, DOE may, in fact, take over some of the responsibilities if the next two bills are passed for industrial information sharing with respect to the energy sector, with respect to cybersecurity and sharing of indications of compromise. Next slide. But to take back a little bit what I have said, you never know where talent is going to pop up. Basically, I was called this week, and turns out that the DOD is in fact transitioning technical expertise to DOE. The National Renewable Energy Laboratory, which is a DOD laboratory, recently selected a DOD product for integration at their facilities. This was a product produced by Schweitzer Engineering Laboratories for microgrids. The capability has multiple applications insofar as it is an interface between various inverters that would be found in the field and distribution systems that to which they are applied. The work was developed under funding by CERDEC, the Communications Electronics Research and Development Engineering Center, I believe out on the East Coast. And the team includes Schneider Electric, CERDEC, MIT, and the Corps of Engineers. It was selected by DOE for integration into its own system. So as I said, ICS S&T research and development flows in multiple directions across between all these partners. Next slide. So now I'm getting to a couple of problem areas. All is not rosy, even within DOD. So I've got a few axes to grind, and they're not my personal axes. These are the concerns that come out of OSD, the Office of Secretary of Defense, particularly the Office of Energy, Installation, and Environment. The Assistant Secretary of Defense for Energy, Installation, and Environment has a cybersecurity representative. He's a one-man dynamo, Daryl Hagley, and I will send you his contact information at request. So, number one, the concern currently is the problem within ICS of utilities privatization. Some years ago, over 10 years ago, under U.S. Code 2688, DOD was directed to undertake privatization of utilities that were previously operated by DOD personnel. This contracting effort started long before the cybersecurity federalization program started within the U.S. government. The head of the contracting agency for UP, Utilities Privatization, is DLA down at Fort Belvoir, and ASD is exercising oversight over DLA in the transition to these utilities. However, there are some problems. Next slide. So as I said, RMF, the National Institute of Standards and Technology Risk Management Framework, was not adopted by DOD until March of 2014 with the issue of DOD Instruction 851001, which replaced DIACAP as a result of cybersecurity federalization within DOD with RMF. However, as I said, the privatization process had been going on for some time, and the contracts were being let without reference to implementation of the NIST RMF, of the RMF framework. ASD EI&E subsequently required in 2016 that all critical facilities managers also specifically implement the NIST RMF framework, which by many people's assumption had been exempted because they weren't directly connected with the Department of Defense Information Network, or DOD. However, it was quite a shock when Secretary of Defense sided with ASD EI&E, i.e. Darrell, and said, yes, these critical infrastructure information networks, even if they aren't specifically part of the DoD information network, but our control systems, must, in fact, conform to the same RMF standards as the rest of the DoD. In one stroke of a pen, the Navy Facilities Command, or NAVFAC, became the largest element in the DoD information network, which was quite a surprise. I was at NSA when that was announced. Now, the problem is there is no contractual basis under utilities privatization for ensuring that RMF standards are complied with. And the same problem occurs when DoD leases buildings as well. Contractually, many of the leases that currently exist do not have the requirement that the owners incorporate and practice the continuous monitoring under RMF. It is a problem. Next slide. So ASD EI&E would like to be able to propose modifications to the Defense Federal Acquisition Regulations to require RMF compliance on these contracts. Some specific examples that Darrell brought up was that within 60 days of award of a contract, the recipients submit a system security plan for their ICS systems, provide a plan of action and milestones for corrective action in making their systems comply with RMF, that they specify their incident response plan and procedures, as well as integrating their data handling and marking policy with the rest of DoD. This should mirror current DFARS clauses 7012. Next slide. Another interesting problem. This is defense support for civilian authorities. Once these facilities do, in fact, come under control of civilian contractors and are now privately owned, the DoD has not the authority to enter those facilities for oversight or response to attack and remediation. All of these actions on the part of DoD installation commanders, base commanders, etc., come under DISCA. There's a problem with DISCA. However, the General Accounting Office did a survey of the concurrent procedures, this was back in 2016, of the process and procedures that exist in DoD for DISCA response to a cybersecurity incident. It turns out, as you can see there, DoD has not yet determined what approach it would take to support a civil authority. This means that there's certain uncertainty as to who responds, to whom, with what, in case of a major cybersecurity incident. at a critical facility. DHS recognizes that, as a matter of fact, under current law, they're in charge. DOD has to, in fact, go through a number of hoops, not least of which is to notify governors of states that they would need to be mobilized to support a civilian contractor in the case of a cybersecurity incident. Next slide. So now I'll move to some takeaways from the last ICS Joint Working Group. So the National Cybersecurity and Communications Integration Center is becoming DHS's main portal for access both to cybersecurity writ large as well as industrial control system cybersecurity. They have, in fact, incorporated industrial control systems response team members, ICS CERT members, onto the NCIC watch floor. NCIC will also soon become the preferred access portal for contact within the U.S. for both U.S. CERT as well as ICS CERT. And to this end, ICS CERT will also be receiving, under the FY18 budget, an increase of $17 million in operations technology support for mission essentials functions under the supervision of NCIC. Side note for DOD, the $15 million plus up that was in the last 2018 National Defense Authorization Act was excised. It was removed. DOD loses $15 million, DHS gains $17 million in the area of industrial control system cybersecurity. So it becomes clear that further cooperation between DHS and DOD not only is preferred, it's necessary. Next slide. Okay, so I would like you to contact Daryl Hagley. He is the cybersecurity representative at OSD EINE if you have further questions, or you can refer them to me and I'll forward them to Daryl. And that is the end of my briefing. So at this point, I will turn the discussion over to Ross Rowley. And he will talk about MOSAICS, which is another DOD ICS controlled systems effort.
Thank you, Paul. This is Ross Rowley. Good morning from Hawaii. Good afternoon to all of you out on the mainland and the East Coast. But I'm a Battelle contractor embedded at U.S. Pacific Command. At a recent speaking event, they misspelled it and said battle. So I think that's pretty cool, but Battelle is actually where I live. Next slide. Speaking of Daryl Hagley, this is a slide that he built. No, back up one. This is a slide that he built that really summarizes the state of DOD ICS Cyber Security. On the left-hand side is all the things that are wrong. It's not on the scorecard. If you don't measure it, it's not going to get fixed, right? There's no ownership policy. There's no inventory. There's no tools. There's no training. There's no people to do this job. So we are largely undefended in this space. The lower right bar graph shows the Mark Center. Those of you who know, it's sort of a Pentagon annex, has thousands of people in it. It's a relatively new building. It has 10,000 security devices, 20,000 information system devices, 50,000 control system devices. And that's one of the reasons why the inventory is taking so long for the services to do. And in the upper right-hand corner is a pie chart that shows the budget from several years ago. The blue wedge, the large wedge there, is the overall IT budget in DOD, which is, a large portion of $39 billion overall. Cyber, the yellow wedge, is a portion of that. And then what you cannot see is the platform IT control system budget, which is an invisible white wedge. Next slide. So that sort of leads the discussion into MOSAICS. More situational awareness for industrial control system. If we could go, there we go. This is a PACOM Northcom led initiative, a JCTD proposal Bill Berry at US Northcom is the operational manager there. I'm the operational manager for Paycom. We've got Sandia on board, Dr. Wagaman, who's on the line. Rich Scalco at Spaywar is our technical manager. Next slide. So the problem statement is basically what I just described to you. Right now, there are 0 people actively defending our control system networks on DoD, and they have 0 tools. We want to provide them with a tool with which to do their job. Next slide. You can see along the bottom here the major control systems of concern to the Department of Defense: water, electric grid, fuel, and buildings. And then in the upper left are the people that we're providing this tool to: ICS operators and cyber defenders. It's both the IT and the engineering side of the equation. And then they are going to use that to defend their control systems, which enable joint warfighter operations over there in the right side. The real crux of the scope for a MOSAICS is in that set of arrows in the middle. There is some tactics, techniques, and procedures already published by Cybercom called ACI TTPs, Advanced Cyber Industrial Control System TTPs. It has a checklist for how a cyber defender would detect, mitigate, and recover from a cyber attack. What we're going to do is automate this using technology from Johns Hopkins Applied Physics Lab. They've already proven this with banking procedures and IT procedures, and they want to do it for ICS procedures. So the detect, mitigate, and recover will be automated. We're adding in analyze, visualize, decide, and information sharing as additional parts of the scope. And that's going to be brought to the team through both commercial off-the-shelf and government off-the-shelf technologies. We have the 3 DOE labs from the Cyber Park involved. They've got their technologies. The DOD labs have technologies. And then the industry has technologies. We're in the process right now of doing a GOTS-COTS survey. And once we narrow that down, we're going to package that with this automation, the orchestration process that Johns Hopkins is doing, and package that and send it to a set of demonstrations. Next slide. The real benefit of this, you can see in the lower left, the main one I want to bring your attention to is the third one there. We're going to go from months to minutes. Johns Hopkins has proven that they can do this, ultimately many times faster by automating it, which puts it into cyber relevant time. Right now, it takes anywhere from 3 months to 9 months to detect and respond to a cyber attack. Our hope is to speed that up innumerably. Next slide. With any project, the value of it is going to be in the transition strategy. How do we get this in the hands of the warfighters long term? So we've got a team led by NAVFAC XWIC, Naval Facilities Engineering Command, Engineering Expeditionary Warfare Center in Port Hueneme, California. They're in charge of the transition. The Navy folks have already decided. The letter that you can barely see on there is a letter from the CIO, NAVFAC CIO. They are going to transition. They've put $25 million aside to transition MOSAICS out to the fleet through the installations, the naval installations across the world once MOSAICS is done. The Air Force also has $25 million set aside. They have not committed it to a MOSAICS transition, but if MOSAICS is successful, we're confident that that's what they would do. We also are going to have leave behind technologies at NICTAM's PAC in Hawaii, because that's going to be our final demonstration site. So they're going to have that long term. And our goal is to make a dent in this whole process. It's not going to be, one solution that fixes everything for us, but it will put a tool in the hands of the cyber defenders. Next slide. And here's our team. It's a really good team. We've got the multiple combatant commands, including Cybercom and Transcom. We've got the DOE labs, Johns Hopkins and SPAWAR, all 3 services, and we're partnering with industry as well. And that concludes my presentation. I look forward to hearing from questions.
Okay, and there's your MOSAICS points of contact, and now we will turn this over to Sandia and DOE. Sarah, you're up.
Thank you. I'm Sarah Hostetler from Sandia National Labs. So we have some time for questions. I'm gonna jump through my slides a little quicker. So first I'm gonna talk about the active and passive IC analysis. So you guys already know what the problem is. So what I'm talking about today is a suite of tools that we call VADAR. It doesn't stand for any acronym, it just means see to understand. What we're trying to do here is a defense in depth. We want to get in and look at what's really going on in the OT network. So where we're really focused is in those middle swim lanes you see here as a, sort of zoomed in view of the Purdue model. So we're focused on where the ICS protocols are going across, and then right up close to the field devices, the PLCs and the RTUs. So we're not concerned yet with the sensors and actuators. That would be great, but there's a lot of diversity there we're not going to tackle right now. And then we're going to figure that the IT coverage for making sure your IT network is secure is really well covered. So everything to the left of the HMIs we're not worried about either. Where we're focusing is we have two tools I'm going to just highlight real quick today. We have one called Archimedes, which looks at the protocol traffic at TCP/IP level from the OT network, and then we have one called PEAT, which looks at directly interfacing with the PLCs and getting information from there. So I'll talk about Archimedes a little bit. Archimedes is basically a way to statistically watch register values, sort of do a heuristic approach to determining what is normal behavior for that network. So do these register values change over time like we expect? So it sort of trains on that OT network and then determines what's normal. So for example, if temperature rises, you can do some inferring that, well, then pressure should rise in this other value. So it's not just the particular values, but how they change over time. And then it will be visualized in some open source visualization tools, the ELK stack. Archimedes is also written in Python, so it's field updatable. Typically our tools, we've worked with, partner with ICS CERT, and we've helped them have tool sets to help their incident response teams. And so that's where we've done a lot of our focus. We want to help them do situational awareness. So again, as I mentioned, I already covered all this, but it's in Python, and we're watching values over time. So the important thing would be then, if you know what your normal behavior is for those register values on your OT network, then you could see some zero-day things. You could determine that, hey, even though an on and off register value is okay, the constant switching back and forth over time, like in crash override, you would be able to see that on your visualization dashboard if you had a tool like Archimedes watching your traffic. So, and then the next tool, how about, is PEAT. It's PLC extraction and analysis tool. And this is where we talk whatever protocol the particular PLC supports and talk to it directly. And we will pull process logic code. And you can do that in sort of a collection forensic way, or if you're the facility owner, you could do this periodically every hour, every night. And basically you're looking to see what's changed. In the past, previous years, we'd also looked at, hey, can we take bytecode relay ladder logic and decompile it into a structured text-like result? And then your process expert could look at that. But we found in dealing with some of the customers that they weren't interested in looking into the internals of the process logic, just in knowing that it had changed. So our focus going forward is how do you determine changes in configuration, changes in process logic, and then bring that in eventually to a visualization tool that will help you determine, hey, what's going on in your OT network. And again, PEAT is also, most of it is written in Python. We use a lot of open source tools. We do some black box analysis. It just really depends on what type of PLC you're looking at, to what you need to do to talk to it and pull that process logic and that configuration data. So anything that could get in and change your process logic, if you're using a tool like PEAT, you're going out of band. It's independent verification from the vendor tools. You don't have to wait for your integrator to come by and pull it with his engineering workstation. You can tell right away that something has changed. So potentially, if you had something like this, you could look for a change like what happened with Trisis. So what we're trying to improve with our research is basically figure out what is on that OT network as is, not as designed, not what the integrator has, but what's actually running. So we want to help improve situational awareness and make sure that we're directly in the path not behind the HMI in areas where there could be, you know, not true data coming through. So we want to do, or kind of our theme is we want to be able to detect the heist, not the break-in. We want to have the camera in the safe to know when the money is gone. We don't want to wait for somebody to notice broken glass at the window. That's sort of our theme. The next steps, we want to move from detecting to how do we do reaction phase, and how do we get the system back to a safe state, to, you know, maybe a lower production level state, but it's still something that they can operate in a compromised environment. Those are where we're researching now. Limitations, obviously our tools have limitations because a lot of this is lab use and, you know, and it's researching. But we've also gone out and partnered with some government sponsors to go out and get some field data, so it's improving. Then we got a little quick philosophical pitch here of being able, transparency is really good for when you want to verify your system. We want verification and validation. And so a little philosophical analogy here is that we believe that OT, ICS protocol traffic is like a school bus. It's very regular, you know the time it's going to go, when it's going to, where it's going to. None of it's secret. You can look in, see all the values, see the kids that are safe. So if a school bus is going 90 miles down the highway and then makes a quick turn into the casino, somebody's going to call that in. That's not right. Now, encrypted traffic is like a limousine. So there's a celebrity in there. It's a secret. They don't want anybody to know. Wherever it goes, who knows, right? Some big important person, no one's going to call it in if they whip it 90 miles into the casino. But what happens when you black out the windows in the school bus? Do you know there's school kids in there? What's going on in there? Nope, we have no idea. So once you encrypt traffic, it cannot be verified what's inside. And so then tools like Archimedes and like Beat can't tell you, can't verify for you what's going on in your OT network. So we would like to see authentication rather than encryption. That's sort of our last little sales pitch. And now it's to Jordan.
All right, hey everybody, this is Jordan Henry, another staff member here at Sandia National Labs. John or somebody, do we have the high-res version of this, Andy, that we could pull up the slide?
And Johnny's wanting to know if you could do.
Excellent, perfect, thank you. So yeah, I'm gonna spend a few minutes here again, going kind of fast so we have some time for questions, talking a little bit about Scepter. Scepter is Sandia's industrial control system modeling and simulation capability. And really the goal with Scepter is to simulate and emulate environments where you can do research and development, testing, evaluation, vulnerability analyses, you name it, basically in a safe sandbox environment, right? So it's an environment that gives you access to operationally relevant environment to do, you know, various case studies on. So basically what I really want to focus on and where we think Scepter is unique is not the fact that we can deploy virtual machines, right, to network them together, or the fact that we can, you know, stand up a power simulation, right, to simulate the voltages and currents, right? There's lots of people doing both of those things. Where Scepter is unique is that we take the technologies and virtualization, right, deploying VMs, software-defined networking to network them together, and we take the technologies, right, of power simulations capabilities, and we combine them together into one environment where you could understand what the physical impacts would be due to a cyber event and industrial control systems. And so at the very bottom there, we use industry standard software to do the end process simulations. In this particular case, we're showing, we're I guess focusing in on grid simulations, so power. But we also have the capability to do batch processes, things like water treatment processes or oil and gas refineries. And then what we do is we link that data, we use the data in those end process simulations and propagate them up to both simulated and physical devices that we include as hardware in the loop, so that we can stimulate the I/O of both the physical devices and the simulated devices, so they think that they're, let's say, monitoring the voltage and current on the transmission line, for instance, or maybe they're monitoring the state of a solenoid valve, right, and then allowing you to change the state of that valve. So essentially, what you can do in these environments is that they're live and operationally realistic. And what I mean by that is you can include COP software, things like industry standard SCADA application software that you're using, let's say, for an HMI or an OPC server. And that industry standard software can talk the full fidelity protocols to both the virtual and the physical devices that we include in the environment. So our virtual devices themselves, where we're simulating the behavior of the RTUs, PLCs, IEDs like relays, we're not emulating vendor products, right? I just want to make that clear. We're not emulating a physical device that you would see in the real world. What we're doing instead is we're simulating the behavior of those devices by linking them to an end process simulation and then configuring them with the full SCADA protocol stacks. So from a network perspective, you would be very hard pressed to find to see a difference between one of our virtual devices and a physical device that's there on the network. And so standing up these environments that kind of look and feel like a real system, right, where we're not generating any fictitious traffic, right? We're standing up environments where you can have a no-kidding SCADA master poll all of the virtual devices just like they would in the real world, and they would respond as you would in the real world. So you could sit on our environments, open up Wireshark, and you would see the protocols being parsed, things like Modbus, DNP3, Goose, whatever SCADA protocol that you have there. So the idea is, one, to deploy these environments so where you can do a number of different use cases. I mentioned some of those, like training, testing, evaluation, research and development. And because they're live operational environments, you can throw an Op4 team on this and actually do threat modeling where they can execute attacks on the ICS environment. So you can do that for training. You can do that to test how effective, let's say, a behavioral analytic is that you're developing. So there's lots of use cases there. And in fact, we were at the ICSJWG and we did a live demonstration where we were able to show the crash override malware actually operating against our virtual devices that were deployed within Scepter, and then we had Archimedes there as well, being able to detect that crash override was running. And then you can take the data that we get out of Scepter and you can extrapolate that out to larger scale effects. You know, how, if the grid goes down in a certain area, how does that affect, my communications infrastructure, emergency response? And that's kind of what we're signaling there in the bottom right-hand corner of the page here. And the last thing I'll mention is that being able to deploy these virtual and emulated environments, we have another tool called, basically our orchestration software tool called Phoenix, which will allow us to deploy X number of environments in parallel, where you can do kind of sensitivity analysis studies if you wanted to, right, where I could deploy 15 identical environments or 15 different environments, right, to do whatever sort of testing. So it's very useful in a lot of the use cases that we have on the research and development side, as well as testing and evaluation. So we're a little over, so I'll leave it at that, and I guess we'll head on to questions, right, Paul?
That is correct. Thank you, Jordan. And in fact, a quick question from me. Could you explain to the audience, in case they're not familiar with it, the differences between simulation, emulation, and stimulation?
Sure. So it's kind of a touchy subject, and sometimes you'll get, 3 different answers from 3 different people. But generally speaking, simulating, right, the simulation side is really the constructive piece of where you're actually just simulating the behaviors, right, of certain components. So, for example, if our virtual devices that we deploy, we're simulating their behavior, right, by deploying a virtual machine that kind of acts like a black box, right, where the request and response characteristics of them would be similar to what you would see in the field, but they're not going to have, right, the they're not going to deploy the actual firmware, right, that the actual device is going to be operating in the field, right? If you wanted to do that, right, you would need an emulator, right, to be able to emulate at the hardware level, right, what those devices are doing. Now we leverage emulation on the x86 world, right, where we emulate, using hypervisor technologies, right, where we leverage the ability of the hypervisors to emulate hardware where we can deploy, let's say, a Windows VM that's running SCADA software. But on the Scepter ICS field device side, we're simulating the behavior by implementing the full protocol stacks, right, and kind of representing the device itself as a black box. If you need, right, higher fidelity, that's why we do a lot of hardware-in-the-loop studies, where if we need that level of fidelity, where we need the actual hardware running the firmware, then we include the real hardware in there as a piece of the environment. Hopefully that answers most of the question.
Right. Okay. Well, I know we're running low on time. I do have a question from Ms. Fournier. I will condense this a little bit. And I think the question that she is asking is that generally cybersecurity expertise resides in the IT community. However, we find out in the ICS cyber domain that you have to have both feet in both domains, both the control domain as well as the IT domain. Her question is, who is training, or how are we training people to have that dual domain expertise? And I have one answer that came from Lieutenant General Schwedo recently from the Rocky Mountain Cybersecurity Conference that was held here in Colorado Springs. And the question came, how do we equip cyber protection teams to have that knowledge of the ICS domain? And General Schwedo said that they are moving to a concept called mission defense teams, or MDTs, as opposed to CPTs. And his response was, the CPTs are more or less the analog of a SWAT team. They're called in for the tough problems, whereas the MDTs, the mission defense teams, are like the local cops on the beat. They know their turf. They call up and ask for support when they find problems they can't deal with. The MDTs will be given site-specific or geographic-specific knowledge that generally the CPTs won't be required to know or be able to know. Anyone else have a response to that question?
Paul, this is Ross. I think that's an accurate way to describe the CPTs, but on a steady state sort of daily methodology, the Navy has come up with the best model that I'm aware of. They actually put CIO offices within the NAVFAC engineering organization. So they've got the engineers and the IT folks side by side working the problem. The Air Force has not gone to that method, nor has the Army or Marine Corps.
Interesting. Okay. All right.
And this is Jordan. I'll make one last comment. We're kind of focusing on DOD theme here. Is that so? CyberGuard and CyberFlag have generally been exercises where you can train folks on the cyber aspects of IT and OT. And in fact, this year, Sandia's supporting, along with PNNL, we're supporting a few dozen teams and deploying industrial control system environments where they can get training on cyber response and ICS.
Mm-hmm. So, are you satisfied that the exercises are sufficient for having a deep enough bench?
So the exercises are a start. They're certainly not sufficient in terms of a holistic view, right, on how we're going to train folks on cyber response for ICS. But it's one of the very few exercises that I've seen where they're actually putting a focus on the ICS side and not just response on a corporate or enterprise environment.
Right. Okay. So Catherine came back with a question. can an IT person walk into a site and gain access in a field location? And the answer is, I would say no, based on my experience. Given the fact that there are distinctions between physical security and who controls physical security and who controls knowledge of the systems. So there are two different things there. Any other questions? Oh, here's one from Keith. How would a utility company that provides energy to DOD, energy to a DOD command, link into the DOD security controls? And so, Kenneth, right now, the answer is, across the federal government, we have federalized our cybersecurity requirements to conform to NIST RMF. So if you're, in fact, in industry and you are voluntarily conforming to the NIST 800 controls, let's say 53 or 82 for ICS, you'll know what the baselines controls are going to be in place or should be in place at a DoD facility.
Paul, there was a previous question from the same individual. He was asking about ISO controls versus the NIST controls. Is there any is there any ISO aspect involved, especially with the utilities privatization, that would come into play?
Well, there are, in fact, ways to map ISO into RMF requirements. I can't go into detail here on that, we're running out of time. ISO, the National Standards Organization, are, in fact, the de facto standards that are used in Europe, as opposed to NIST RMF, which are not. But I think that it's not an issue, or not much of an issue, to do that mapping. Is that an adequate response?
Yes. Okay. Yeah, and so we are, we are running a little long today, a little late today. So I do want to try to wrap things up here. First of all, I want to thank all the presenters for taking the time to share their information and expertise with us. I truly do believe this is one of the most important areas that we need to pay attention to, and secure the infrastructure aspects within the nation, within the DoD function. So, like I said, I appreciate the folks from the different agencies participating in this today. So, and if attendees do have any questions after the fact, if you think of something after after we leave the presentation today, you can follow up, send questions to info@csiac.org, and we'll work on getting the questions out to the presenters to answer these questions. So once again, thanks for attending. Thanks to the presenters, and I'd like to wish everyone have a good day. Take care.